In mathematics, we're often interested in how relationships interact with each other or connect with each other. And one of the ways we do this is by solving systems of linear equations, which are sometimes called simultaneous equations. So we get two equations like this, 3x plus 2y equals 19 and x plus y equals 8. And when we're asked to solve this system of linear equations, we're being asked to find the point at which these two lines intersect. Find the point where the x and y values are the same in each equation. Now we can do this on a graph. We could plot the two lines. The red line is 3x plus 2y equals 19, and the green line is x plus y equals 8. And you can see they cross, or they intersect, and if we plotted this accurately enough, we'd be able to just read off the x and y value. But sometimes your equations don't lend themselves to easy reading on a graph. And so we have some algebraic methods that we can find the x and y value, and one of these is by substitution. So let's go through that. The first thing I'm going to do is I'm going to number my equations 1 and 2 to keep track. The first task I have is to make sure or to isolate from one of my equations either x or y. It doesn't matter which equation I choose, and it doesn't matter if I use x or y. But I'm looking at equation 2 and thinking that would be the easiest to rearrange to get y or x on one side of the equal sign and everything else on the other side. And so I'm going to begin by looking at that. So x plus y equals 8. So if I subtract x from both sides, I end up with y equals 8 minus x. So now I know what y is. I can take that and I can substitute 8 minus x for y in equation 1. Everywhere I see a y in equation 1, I'm going to replace that with 8 minus x. So 3x plus 2y equals 19 becomes 3x plus 2 times 8 minus x, and that equals 19. So the reason I did this substitution is because now my equation only has x values. I can do some expanding and rearranging and find out what 1x is. So this equation becomes 3x plus 2 times 8 is 16. 2 times negative x becomes minus 2x equals 19. I can now gather like terms and rearrange to find 1x. So I have 3x minus 2x equals, if I subtract 16 from both sides, 19 minus 16. So this becomes 3x minus 2x is x. 19 minus 16 is 3. So I get x equals 3. So I know that the common x value in both of these equations is 3. So my next task is to take my x equals 3 and substitute that into one of the equations. It doesn't matter which one, but as 2 produces what looks like the easiest math, I will substitute in there. So x plus y equals 8 becomes 3 plus y equals 8. If I subtract 3 from both sides, I get y equals 8 minus 3, so y equals 5. So my coordinate pair for where these two lines intersect is x equals 3, y equals 5. And if we look closely on the graph, you'll see that x equals 3 and y equals 5.